Alright, so we're going to be putting brand new cells into this battery shell that we recovered previously. This is the one with serial number CS1107. This one had, it looked like a little bit of water had gotten in, and just one little spot of the cells had developed some rust. I don't know if it was humid or water got in, but it was, those cells were toast, and I recycled all the other cells just in case. So I've already taken this apart again, so save some time on that. This was my first time buying cells, brand new cells online, so I was going to go over that real quick. I bought them from the 18650batterystore.com, which came highly recommended. Looking on Reddit, on some of the subreddits for people that work with 18650s a lot, it was one that they recommended as a safe source, because there are a lot of there's a lot of variation in quality between 18650s, and if you get one that is not up to the task of what you're doing with the high current draw that a tool needs, then it could be dangerous. So there's a lot of reasons not to just buy off like eBay or Amazon, because if you're not sure of the quality of what you're getting, it might be a bad idea. They all shipped in these 2-pack plastic cases. I actually got I ordered 2 different kinds of batteries, and they shipped in these 2 different kinds of plastic cases. So the ones we're using today are Samsung 30Q model batteries. They are 3000 milliamp hour each, and they are rated up to 15 amps of continuous current. And these are going to go 10 of them into this pack. The pricing breakdown, so the batteries themselves were $2.95 each, and the total shipping for the whole order for me was $17.75, which works out to about 51 cents per cell for shipping cost. So after shipping, they were $3.46 each, and ends up being about $34.57 to put 10 of these into a pack. And I'm using 2 different kinds of batteries because since these are going 2 in parallel, they can be a lower total amperage rating, and in exchange for that, it's usually a balancing act between maximum amperage and maximum capacity. So going for 15 amps of discharge lets you get up to a 3000 milliamp hour battery in this case. Whereas on the ones that I'm going to do on the battery packs that just take one series, I got batteries that are 2500 milliamps with a 20 amp max discharge. And for the normal Ryobi batteries, like not their HP or Edge or brand new Edge batteries, but their normal batteries, a 20 amp maximum is what the other components are rated for. So they actually came with 15 amp cells in most of these when I took them apart. So most of them were 15 amp batteries anyway, but I'm using the higher 20 amp in the single packs, and then the 15 amp when they're doubled up. So that's that. So we're going to just get right to it. I'm going to open all these up. It's kind of unfortunate that they all ship with these reusable plastic cases. It seems a little wasteful if you're going to be putting them into something, but they all just ship like that by default. I didn't pay extra for that kind of these cases to come with it, so I guess I've got a whole bunch of cases now. Alright, so let's make sure we get this aligned correctly, because the order matters. So let me just make sure. Yeah, so that's the back. This silicone, it's like a soft rubbery silicone sort of alignment piece that goes in the very bottom that the cells sit on. Then they'll have the first row, and then this row of spacer goes in between. That's just some old foam that was on the side so we need to make sure we put these in the right orientation. And if that's the back, then this tower is going to go on here, and that's looking for the ultimate negative to be over here for the pack. So we will put the negative in on that side, and then we just need to alternate all the way up so that we end up with the positive ultimately on this corner. And I'm going to grab my multimeter. It's not the end of the world if these are not all super perfect. We can balance charge them afterwards, but we do want them to be pretty close just to avoid any accidents. So let's just double check the voltage on these. 3.44, 3.44, 3. Oh, these are all, they're all bang on. Those are all exactly the same. So I feel pretty happy about that. This piece, I don't believe, the center spacer, I don't believe has an orientation that it cares about. Just kind of slides, there we go, kind of slides over it. Make sure everything's tucked in correctly. And then we want this to go, so this top row of cells to be in the same orientation as the ones beneath them, so they can all get tied together. So these all just clip in, and we'll double check the charge level on these as well. Okay, so these all shipped at 3.44 exactly. That's really good. I'm happy with that. So the way this will work, I'm trying to think about the easiest way to go about this. I think what I'm going to do is take just a little bit of electrical tape here. It's just so I can use it to kind of hold everything in place really well until I start to get the welds on. There. That way they're not so floppy. Alright, so here's our ultimate negative on this side. So the way this will work, we're going to take, we've got some zinc strip here. Cut this tape off of it. And so this is what we're going to connect all these up with by welding onto the ends here. And so I'm just going to work on cutting some lengths that we need first. Spread this out. And this actually cuts, it's pretty soft, so it's actually a little bit frustrating to try to cut it with like flush cutters or anything. It actually works really good with a pair of scissors. This is kind of boring. I'm going to speed this part of the video up. You guys are not going to hear any of the things I'm saying right now. Okay, so what I did that I just fast forwarded through for you guys, I cut 6 of these longer strips, which are going to be for the ends of the cell, of the pack. So the overall negative, it'll have these tripled up, and the overall positive will have these tripled up. And then these slightly shorter ones, these are going to go on the ends that are connecting the series. So we'll do a short strip that goes connecting the top row to the bottom row, and then we'll also do a pair of these shorter ones that then connect them side to side. So this, I'm not going to double or triple up any of these because these are just by the layout are going to have multiple current paths, so these are effectively doubled up in parallel already. So that should be good. I'm not worried about that. So I think I'm going to start with, and so these ones on the ends I made a little extra long because when this all goes together, this will sit on top. There's another, this is not silicone, but there's another spacer thing on the top. This will go up here, and then I've got to have enough room to make that connection onto the actual circuit board with the overall positive and negative. So that's why I'm making those ones longer. But we don't need those right now. So this is what we're going to be using for our welding today. I did a practice run with this. This is new to me, welder. I did rebuild one other Ryobi battery with it once already for practice. Just using old cells that I had laying around. Okay, so I have rebuilt one Ryobi battery with this welder already, which I did with just some old used cells that I had laying around so that I could test the welder before I got the new cells in, just in case there was too much of a learning curve. But yeah, so this I'm pretty happy with it so far, and I want to double check just before I start putting this in place, double check which end of this is which, because I feel like, okay, that goes that way. Okay, double check it. So this is my negative, so we will start here. So I am starting out in gear 6, and I decided from using this last time that I liked having a 5-second delay, so it kind of forces me to have plenty of time in between welds. So we will put just check that. Yeah, that feels pretty good in gear 6. I might go, oops, I'm changing the wrong thing. I'm going to go up to gear 6.5 and just see how that looks, just for comparison. Yeah, that looks a little bit better. You don't want to like blow holes through the strip ideally, but you want to have a nice solid weld where the middle is fused well. So there's a little bit of a ridge thing in the center of this. Oh, there's like a little plastic kind of piece that sticks out. I'm willing to bet the original strips that connected this were like custom cut into a funky shape for them, which obviously my strips are not. So I'm going to grab, I don't know if this makes sense to remove those little pokey outy bits, at least make them a lot smaller. Yeah, I'm doing it. If it's a bad idea, we're about to learn together. Wonder if that's just part of the molding process, or I'll get the other ones when we switch. Yeah, that lays better now. So the way this welder works, it detects when you make continuity between the two probes, and then it will wait whatever you specify for a delay. I think it goes in half-second increments from half seconds or half a second to 5 seconds. So you can specify what that delay is until it automatically does the welding pulse, which is very user-friendly if you ask me. It's got USB-C, ooh, don't touch those, USB-C recharging, USB-A for an output if you want to use it as a power bank, and it shows you a live temperature reading and battery capacity reading on there for itself, which I think is pretty dang convenient. So that's the overall negative right there. Again, we're gonna triple those up on the ends, but I'm gonna move on to doing the first of these other rows, just because I want to get strips on to help make sure everything stays in alignment, besides just that piece of tape I put around it. Just to kind of be a little extra solid. So I think most of this welding process is going to be pretty uneventful and boring to watch the whole thing through. So I think I am going to plan on fast forwarding this part, or most of it, and I'll just come back into normal speed when I've got something interesting to say. But so what I'm going to do, I'm going to do all these strips in this orientation first, and then we'll go side to side. And the way this works is kind of like a zigzag. So we're going to do, you'll end up with like a square pattern there, and then a square pattern down here as well. And that will make all those connections, so that the ultimate goal here is this is the extreme negative of the pack, and it's going to just zigzag down the line like that. So when we get to this end, we'll have that extra one sticking out, and we'll have a square and a square there, the same way on the other side. So they'll be like a mirror image of each other. So I'm going to fast forward through this, just so it's less annoying for you guys to watch, and then we'll come back in a minute. So that is the welding done. I went up slightly, I ended up using gear 7 on the negative ends of the batteries, but it worked. It needed a little more oomph on the positive terminal, so I did gear 8 on those. And then wherever I was doing the doubled up ones, I did 7, only did gear 7 regardless, because it goes a bit easier. So I'm pretty happy with that. I'm going to turn this off just by holding the power button. Set this aside. We don't need that anymore today. We can take this electrical tape that was helping hold these together. Like so. Don't need that. And now, if we bring our meter in, we should be able to see an overall pack voltage of about 17.21. So everything appears to be connected right. I didn't screw it up yet. So next steps, I'm going to turn on my soldering iron because we are going to need to solder a little bit here. Let's get some solder out. Let's see. So is this going to be best done sitting in its case or just out? Probably just out, I guess. So if we set this right on top, so you can see this positive connection connects right up to that. And with all that solder there on top, I think I'm probably going to be okay to just flood this whole thing with solder, and that'll be the positive. And I think the negative will end up doing pretty much the same thing. Just flood solder onto, there's like the little remnants of the old tabs on there. I think I'll just be able to flood in there. And then on the sides here, so these, the overall negative and the overall positive, when you're using the battery on a tool, the main power flows through those. These other ones are just for sensing, so that the PCB can monitor those cells and make sure that none of them are going overcharged or over discharged. So there's almost no current going through those ever. So we actually, so that doesn't need to be like extra beefy or anything as far as, you know, the number of layers of nickel strip or anything that you use. Those are not terribly critical because no real current flows. It's just a voltage sense. So, do I want to, I've got options though. I can, if I want, just use the welder again and tack a little bit of strip on to connect the old, they had used strips on this one. Some Ryobi batteries, there's actually a little bit of wire lead that comes off, and some of them have a piece of nickel strip that goes up to the circuit board. I think I'm just going to connect some wire though. I don't think I need to use more strip on it. I have some wire. What do we got? What do we got? This is some, I think this is 22 gauge PVC. I can't read it. It's too small and I'm too old. I think this is 22 gauge. Anyway, it hardly matters. Again, it's just for voltage sense. So we're gonna, well, scissors are not the right tool for that particular job. Let's grab some snippy snips and make a couple. Oh, that's gross. I'm going to clean up the end of that wire for next time. Definitely use the right tool for the job. I'll clean up the end of that just in case. So we just need, like this is, just need a tiny little bit of this. This is probably enough for 3 of these, I bet. But maybe if I, yeah, I'm going to cut it in half. We just need a couple little pieces like that. We'll grab one more. How many do we need? 3 of those. So we got there. So you're going to do a sense wire to this group, and to this group, and to this group. Oh, so we need 4 of them. Yep. Learn to count with Gary. So we'll put that there. Put that wire away. Let's grab some strippers. So we are just going to pull off the ends here. saying this is almost overkill. So you want to make sure, you definitely do need to make sure that this is going to be as flat as possible, because there's very little clearance on the sides when this goes into the case here, right? Do this carefully. There's almost zero clearance, so you need to make sure this is going to be very flat, or you're going to have a risk of like pinching those cables and causing some goofs later. So be mindful of that. But I'm going to expose these ends with my strippers. Come on out of there. It's a little bit harder when they're so short you can't barely grab onto the wire with your hand and get leverage to pull. Okay, sorry, I got interrupted there for a second. So we are just going to plan this out a little bit so I can see how I want to do this for each one. So, and I don't want this to, so this isn't actually held on to the batteries in any way. It's just sitting there. So I got to be careful and make sure I don't let it lift off too much. So I'm going to, I think what I'm going to do is trying to decide if I want to take those old strips off completely and just put my wires directly up there. That's unnecessary. I think this will be okay. Alright, so we're going to make this one. Oh, nice ink strip. Maybe I shouldn't have cut that tape. Alright. So we are going, I'm almost out of solder on this roll. I've got more if we need it, but I want to use this up all the way first. And where is, pardon my reach in front of the camera. Just got to wet my sponge for the soldering iron here. We're going to wet our tip. I'm just going to tin the tip of each of these real quick here. Whoop. This. Okay, so there's our wires tipped, or tinned rather. And I think I'm going to, so what I don't want for sure is to allow these hard edges to remain for to accidentally rub on the wires or something. So I'm just going to cut these short, just because, oof, those are not cuttable. That's definitely, that must be steel right there then, huh? That's hard. Does this thing stick to it? It's hard to tell. I can't tell, but it certainly wasn't going to cut with that. Let's grab some flush cutters, because the alternative is that I got to undo these screws and take the whole PCB off of this plastic carrier. Crud. Alright, I think I'm going to have to do that. So we're going to undo these screws, and we're going to have to remove all those, because that wants to be difficult. It's not the end of the world. So let's grab an appropriate tip. Is that too big? Nope, that's okay. that in there. And this ratchet might be a little loud. Never mind, these are so short it barely has time to ratchet at all. In fact, I should grab a smaller one to put this back on with, because I feel like I want to be careful that I don't strip the little plastic holes they're going into. Now this should come away. Oh yeah, except for that temperature sensor that's over there. That's going to be difficult for me. But that's okay. We can make this work. Alright. I'm going to... Alright. Let me think for a second on how best to organize this. I don't want to, I need to like, alright, let's try this. Let me, see what they've done is they've got this temperature sensor right there, and it's like potted into here with like silicone or something, and I want to be very careful because breaking that would be bad. It would. So let's see if we can just get in here with this and try and pull this out. Ooh, well, that's actually working pretty good. Let's grab something so I don't burn my fingies. Is that coming out? Almost. There it goes. Yeah, you can see that narrows to like a thin little tab in there. So that's pretty good. Alright, there's 2 down. This is actually going pretty good. Try to get this guy right next to that thermometer. Woo. Okay, we're not failed yet. This one is going to be, I don't know if this one's going to come out. Whoop. Nope, that's not working very well at all. I don't have room to work with. Alright, different tactic on that one. Where's my solder sucker? Different tactic. Let's try to take all this solder away then. Ho ho ho, that looked good. Yoink. So now let's try, just loosen the last of that. Oh, come on, man. The other thing I could do, I don't want to. Alright, so what I'm going to try is to get a little corner of a blade up there, just so I can try to get this to lift away from the plastic spacer. Try to be super careful. I don't know if I'm off camera right now, but I'm trying to be real careful, so just give me a minute. Oh my gosh, it worked. Well, now I wish I had just done that to begin with. Alright. Put my knife away here. Now we can put our solder sucker out of the way. So now let's put a little gentle pull on that tab and heat it. I've gotten rid of most of the solder so it's harder to heat. Be patient, I don't want to accidentally rip one of the pads. Let's get a little, whoop, let's wet my tip here. There it goes. Ta-da! And there's that out. So, alright, all these tabs are just trash. That's solder I sucked up as trash. Solder, solder, whichever. Oof, that came out a little ugly, but it's okay. Okay, so which end is which of this? Maybe Gary should have paid attention. Oh, that lines up with that, obviously. Okay. Do I want to... So I actually don't want to remove the overall positive and negative, I don't think, because I'm worried these slots that they're feeding into are going to be a weird or specific size that my tabs won't fit into. So instead, I'm just going to make sure these don't protrude past this plastic carriage at all, and call that good enough, because their existing tabs being soldered into place should be a really good connection. So if I just make sure that I've got a good connection to their little stub ends or their solder ball on top, then I feel like I can be relatively safe with that. So let's slot that back into place. Oh, that worked really well. I'll have to remember that. That is an option. Let's grab a smaller screwdriver. Here we go. So we don't want to strip these holes, so we're just going to back it out slightly till we feel where the threads start. If you don't know that trick, when you're screwing into a plastic hole that's already been screwed before, go backwards with your screw at first and let it kind of ride that top thread. Whoop, and then you'll feel where it kind of like finds the beginning of the thread. You can usually hear it click actually even, so I'm pretty happy with that. And then that way it's much less likely that you'll accidentally jump the threads or strip the hole. And there we are, secured back onto our plastic carrier. These ends are recessed so they're not proud of anything. Bring this back out, make sure we're oriented right. Got the overall negative in the back right there. And now we are sitting pretty. Alright. So now we can plan connecting these things. So I'm going to get some fresh solder. I'm going to put just a little bit on each one of these joints now that I had just taken stuff away from. So I'm just going to get some nice fresh stuff on here, make sure there's plenty of easy contact on there to be had. Just flooding it. There's technically a hole in there that I could try to stick the wire through, but that's unnecessary. So I think I'm going to do this one over here. This is a little bit longer piece of wire I pulled off, and this is a little bit of a longer reach. So that makes sense to me. Melt that into there. He said not melting. There we go. Whew. These tiny little wires heat up quick. And this guy can go there. I'm going to go ahead and grab, where's those tweezers I was just using? There they are. Because I'm a baby and I don't want to burn my little fingies. Is that alright with you? Okay. So once we've got all these wires tacked on, and I should be pretty safe. And again, these are just sense wires, so very low on the critical scale. This guy can probably be made a lot shorter. I'm going to strip this one down shorter, because he's way longer than he needs to be. How's that? That's a lot better. So I was looking again at those wires when I was interrupted earlier. I know it's either 20 or 22 gauge, but I'm not positive. I think it's 22, but I couldn't see the printing on there to be sure. So who knows, I guess. I'm just going to re-tin this end here. Yikes. Big Clive makes that look very easy to hold the item and the solder and the iron all at the same time, and it's not. It's definitely not. Alright, so now we are going to put a little pool of solder right here in between these batteries, like in the middle of the strip here, not directly on one of the cells. And I'm just using my iron to do a couple scratches on it first, just to help give it a little something to touch. Then we can take these wires, make sure the overall plastic spacer thing is sitting down nice and flush the way it needs to be. Then just make that connection. Hold that in place and make that connection. Okay. This one's, whoop. Going to go right here. That doesn't really want to scratch up for me, does it? That's okay. Let's turn our temperature up a little bit. That go. There's that one. And where's that wire gonna fit? That's gonna fit right there, just perfect, I think. So hold that nice and tight where it needs to be. Make that connection. There we are. Hold that down nice and tight. Make that connection. Oh. Make that connection. My iron's gotten dry. There we go. Much better. Okay. So now the next thing I'm going to do is I'm going to kind of fan these ends out and get like a whole mess of solder on these ends. Get them so I can fold them over. Something stronger. Hey, yowzers, that's still warm. Okay. There's a lesson you have to learn a ridiculous number of times when you start soldering. Things stay hot for a long time. That is not doing what I want. Flood it a lot. Well, you know what I didn't do is add fresh solder to the underneath. It's probably my problem. Oh, gone and undid my progress. Underestimated the springiness. Alright. Stop messing with that end, Gary. Yeah, see, all the down here is still cool enough to touch. So we did not come anywhere near too hot for that. How do I want to do this one? First of all, whoops, the solder fell off the roll. First, I want to get nice fresh stuff all over this connection. And then probably I'll put a bunch on these existing tabs. Get those kind of flooded. Then we will get a bunch of it up on our strip here. to do is pretty much just heat this all up, fold this all over, and flood it all over with fresh solder and heat so that we've got a very solid connection. Feel everything under there go nice and loosey-goosey. It's all melted underneath. Just hold down those. Now we just let that cool. Awesome. Awesome sauce. Yeah, that did not get very hot down below at all. So that all worked well. All of our connections are made. Turn the iron down a bit. So now, in theory, we should be ready to test this. So we need to put in the bottom piece, which goes like this, like so. Then this piece goes in top like so. And then this little connector. This is the connector for the battery charge indicator on the front that this model has, which is annoyingly short. Golly, that is too little for my fat fingers by themselves. We need to get in here with a little assistance. Oh gosh, that is very frustrating to put back in place, isn't it? Doing it right, aren't I? Yep. It's not something that I can take that out first, is it? Oh. Well, here we go. Almost. Almost, maybe. Kinda, sorta. Oh, for crying out loud. Why is this the hardest part? There we go. Gotcha. Alright, let's see what it does. Alright, it shows a light. Shows red. Is that red or orange? It's kind of hard to tell. Let me turn this off for a minute. Oof. I guess that's red. I'm not sure what colors this thing has for display. I know it's various like green, yellow, red. I don't know if there's any more specifics to that. So let's, before we put that on, let's put a meter across the output terminals and see. Oof, everything's gotten all askew. Whoops. Sorry. I'm looking into the camera trying to see if I'm in shot instead of Alright. Drop everything and make a mess. That's okay. Alright, so this, I think this is the backwards, yeah, 17.2. So we're getting the correct voltage on the output. We already know they were balanced when we started because we checked and they were all at 3.44. Pretty much bang on. Oh, I need to put the sides in. Not the sides, the little springy clip part. Pull this back out. This particular battery, the contacts are very tight, so once you slide them into that tower, they're hard to get out. I don't mean this particular model necessarily, but this specific one. Alright, so how does this go? These go like this, I believe. And then these plastic wings. So those are the springs that hold the plastic wings in place for when you put it on a battery. I mean, put it on a tool. Now we can put this back on. line up those clips on the side, make sure they clip in. There's that. Now we can put the screws back into this. What do we need? T10. Is that the other one? Yeah, T15. Alright. So this one on the top is a T10 for this particular battery. Okay, so there it is, reassembled, giving an indication, giving power on the output. Let's plug it into something. Well, it seems like it's working. Let's try popping it into a charger real quick. Let's see what this does. Is this plugged in? Might not be plugged in. Might be helpful if we plug that in.
I must be the luckiest girl in town.
And so you can see it's analyzing and it's charging. So it's all working. So that is brand new now. And I'll have to put a new label on there to myself. So we used 3,000 milliamp hour batteries, and we used 2 of them in parallel. So now this is a 6 amp hour battery, as opposed to, what was it before? 48 watt hour. I think this was a 2.5 amp hour, I want to say. I'll have to do the math on that. I'll put it in the comments. But it's a 6 amp hour now. So that's a win. Cool. Thanks, guys.